In this video, we're going to talk about factoring special products. All right, here are my two examples. The pattern that we're going to look at in section 10.7 is the difference of squares. Difference, meaning subtract. Squares, meaning perfect squares. So when I look at question number 1, I know that I can factor this because, first of all, it's a difference. In addition to it being a difference or subtraction, I know that the first term and the last term are perfect squares. So I can factor this into x minus 8 times x plus 8. So when I have a difference of squares, my answer is going to look very similar to this, where I'm going to have a subtraction sign and an addition sign in opposite binomials. To check my work, I can always go back and use FOIL. So my answer's in red, but my check's going to be in black here. X times x is x squared plus 8x minus 8x minus 64. Now you'll notice when I have two binomials that are pretty much identical, except one has plus and one has subtraction in it, what's going to happen here when I use FOIL is my two middle terms are going to cancel out, leaving me with x squared minus 64. This is what I originally started with, so I know that I factored my answer correctly. So this is my final answer. All right, let's look at question number 2. I've got 16 squared minus 36. Now the question is, can I factor it using the difference of squares? Well, I have subtraction, so I know it's a difference, and 16x squared and 36 are both perfect squares. So I can go ahead and factor those. All right, so I can factor these into, let's see here, the square root of 16x squared. That's going to give me 4x. Square root of 36 is 6. So I'm going to factor that into 4x minus 6 times 4x plus 6. Okay, now before you officially call yourself factored here, I want you to ask yourself if you have any greatest common factor in either binomial. And I hope that you'll see there's a greatest common factor here of 2 and in my second binomial of 2. So I need to factor a 2 out of both binomials. So when I do that, when I factor my first binomial, it's going to look like this. 2 times 2x minus 3. Then I can factor another 2 out of my second binomial. So I'm going to put that other 2, my greatest common factor 2, out front. I'm going to multiply it by my original 2 that I took out. So that's going to be 2x plus 3. So now I just have to simplify my 2 times 2. So I'm going to have 4 times 2x minus 3 times 2x plus 3. Now, to avoid taking out a greatest common factor in the end, like I had to do there, I could have taken my greatest common factor out at the beginning. So if I look at my original problem, I could have factored a 4 out right away. So let me just redo this problem here. If I would have factored my 4 out right away, it would have looked like this. 4 times 4x squared minus 9. And then from here, I could have used the difference of squares to factor this. So it would look like this. 4 times 2x minus 3 times 2x plus 3. I always think it's easier to factor out the greatest common factor at the beginning as opposed to the end, like how I originally did the problem. But either way, it will work if you do your math correctly. So you get to choose what's going to work best for you. But just make sure you take out that greatest common factor.